Okay, here we go. Lesson 4, permutations. So a permutation is an arrangement of a set of objects in which the order of the objects is important. So the permutations of the letters in the word dog. So we're going to go D-O-G, and then we've got D-G-O. Those are the ones that start with D. And then we've got O-D-G and O-G-D. We have G-D-O, and we also have G-O-D. So in total, there's 6 ways. And if we were going to do this using the FCP, there's 3 letters to pick from for the first one, multiplied by 2 remaining, and then you're left with 1, so there's still 6 ways. And we called this 3 factorial. So a number of different ways that you can figure out the permutations of the letters in the word dog. Draw them out, use the FCP, or use factorial. Okay. So just to highlight this, the number of permutations of n objects taken all at a time is n factorial. So meet, there's 4 letters. So 4 factorial is 24. So you could arrange the letters M-E-A-N-T 24 different ways. Mexico, there's 6 letters, so 6 factorial. You could arrange all those letters 720 ways. So use the fundamental counting principle to find the number of 3-letter arrangements that can be made from the letters of this word. So there are 8 letters, okay? And we're doing 3-letter words. So I'd have 8 choices multiplied by 7 choices multiplied by 6. So that would give us 336 3-letter words. So on your graphing calculators, I want you to press math. Well, turn it on first. Math, and then PRB for probability, and then select the second choice, which is NPR. Okay, so math, probability, and select the second choice, NPR. Now I want you to type in 8 for the 8 letters, and then I want you to pick 3 for the number of 3-letter permutations, and you'll see that we get the same answer. 8P3 gives us 336 ways, which is samesies. So here's something that you will need to know. Okay, NPR is the same as n factorial divided by n minus r factorial. Okay, n is the total number of things. R is the number of objects you're taking at one time. So 8p3 is going to be the same as 8 factorial over 8 minus 3 factorial, which is 8 factorial over 5. And if you want to expand this, 8 times 7 times 6 times 5 over top of 5 factorial, those cancel out, and you still get your 336. So let's evaluate 10p6. Let's do it by hand. So this is going to equal 10 factorial over 10 minus 6 factorial over 4. And if you wanted to expand that, 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial over 4. Those cancel. So 10 times 9 times 8 times 7 times 6 times 5 will give you 151,200. And if you want to do it a little bit quicker, type in 10 and 6, and you get the same thing. Use the formula to determine how many 5-letter arrangements in the word cabinet can be made. Well, how many letters are there, first of all? There is going to be 7 letters. So 7p5. So math, probability, 7 and 5 gives us 2,520. Okay. And the way we were doing it before is we'd have 5-letter arrangements, and you'd have 7 choices, and then 6 choices, 5 choices, 4, and then 3. And you still get 2,520. Use a formula to determine the number of permutations of all the letters in the word fish. So no restrictions, so it's simply 4 factorial, which gives us 24. And if you wanted to do it like we were before, you'd have 4 options for the first one. Any of them, F, I, S, or H. And then you'd have 3, 2, and 1, and you still get your 24. Sailor, 6 factorial, which is 720. Oops. Okay. It's all for n. Well, what's different about this one? We are missing a variable. So what we're going to do is we're going to use the formula that we got before, that n factorial over n minus r factorial gives us what we need. So we're going to set this equal to 30, and we know that n is still just n factorial. That's what we're looking for. And we can do n minus 2 factorial equals 30. Now, the issue here is what's n factorial? Well, n factorial is n, and then n minus 1, n minus 2 factorial. And that's over top of n minus 2 factorial. So if you notice, this will simplify to 1. So you're left with n minus 1 is equal to 30. And let's expand that. So n squared minus n is 30. And if you bring that all over to one side, you can factor that to n minus 6 and n plus 5. So our solutions here could be n equals 6 or n equals negative 5. But what we learned the other day was you can't have a negative factorial on top, so our solution is only going to be n equals 6. So let's deal with some permutations involving restrictions. In many problems, restrictions are placed in the order in which objects are arranged. When you come across this type of situation, deal with the restrictions first and use the fundamental counting principle instead of the permutation formula. So how many permutations are there in the word Columbia? So there's 8 letters, and there are no restrictions. So if there's no restrictions, you simply do 8 factorial, and you're going to get 40,320. If the first letter must be C, so it must be C, so there's only one way to use C, but then you still have 7, 6, 5, 4, 3, 2, 1 to arrange the rest of it. And if you go ahead and actually calculate that out, you'll get 5,040. And if the last 2 letters must be vowels, we still have an 8-letter word that we're going to arrange. 1, 2, 3, 4, 5, 6, 7, 8. Must be a vowel, must be a vowel. Well, how many vowels are there in the word Columbia? There's O, U, I, and A. So you have 4 options and 3 options. And then because we've used some of them, 6 times 5 times 4 times 3 times 2 times 1. And if you calculate all that out, 8,640. Sometimes certain items must always be kept together. To do these questions, treat the joined items as if they're one object and see where we can arrange them. And then what we'll do is we'll figure out how many ways can we arrange those specialty objects. So for example, we did a picture, like people involved in a picture thing, and I think it was like Braden and Ben had to be on the outside, right? Braden and Ben or something. And then you could arrange, the 3, like Alice and Amy and something or other, in the middle. So you could arrange, you could swap positions all in the middle here, and you could either have, Braden on the left side or Braden on the right side, but you couldn't have them together. So what we're going to do is we're going to kind of treat the O and the M as one thing. All right. And we've got C, O, M. L-U-B-I-N-A. Now, if you can kind of picture these as like Scrabble tiles, right? So there's 7 tiles. The O and the M are going to be on the same tile. So we're going to arrange all of them, which is 7 factorial. Okay. And then if we look at the O and the M specifically, you could do O and M or you could do M and O. So there's going to be 2 factorial ways to arrange OM. And what we'll do is we're going to multiply the 7 factorial by the 2 factorial, and you're going to get 10,080 ways to arrange those. Okay? So it's like we're kind of, switching these Scrabble tiles around. Once we find all those options, you're basically doubling it because the O and the M could be reversed. So here's another example. How many ways can 3 math books, 5 chemistry books, and 7 physics books be arranged on a shelf if the books of each subject must be kept together? So if I can draw a little sort of section here. So let's call this math, and then we'll get our chem and physics. Okay, and you've got 3 books. You've got book, A, B, and C. And then chem, you've got 5 books. So you've got chem A, B, C, D, E. And then physics, you've got 7. So A, B, C, D, E, F, G. Okay. So in this order, you could still be math, but you could do ABC, you could do BAC, you could do CAB, you could do CBA, you could do BCA, and ACB, whatever, okay? And then chem, you could start to do the same thing, but it's going to take you forever. A, B, whatever, D, E, B, C, something or other. Arrange them all specifically. And then the physics, you could do the same thing, right? A, C, B, D, E, F, G, A, C, D, B, E, F, G. It's going to take you all day to do that. Okay, that sucks. Let's not do that. But I hope you get the picture that there's going to be arrangements within those sections. Then you can also arrange where the order in which the books appear. So you could have the physics section first. Okay, and then math and then chem. Or maybe you stick the physics books in between the math and chem. Or maybe you put the chem first. Okay, so you can arrange the sections of the books. So let's figure this out. So the first one is 3 factorial, which are the ways to arrange the math books. Then you've got 5 factorial, which are the ways to arrange the chem. And then you've got 7 factorial, which are the ways to arrange physics. And then you also have 3 factorial, which is the ways to arrange the subjects. Okay. So all together, you're going to get 3 factorial times 5 factorial times 7 factorial times 3 factorial, which gives us 21,772,800. How many permutations of letters in the word poster are there if there's no restrictions? So 6 letters, 6 factorial, 720 ways to arrange those letters. If P, O, and S must be kept together in that order. So P, O, S consider as like a tile, T, E, and R. So we can arrange these tiles. There's 4 tiles, so 4 factorial is 24. We do not have to figure out the arrangements of the POS tile because they have to be in that specific order. However, in this one, P, O, and S are a tile, T is a tile, E is a tile, and R is a tile. So there's 4 factorial ways to arrange tiles, we'll call them. But then the P, O, and S could also be reversed, switched around. So we got to multiply this by 3 factorial, which are the ways to arrange P, O, and S. And if we do that, we get 144 ways. Sometimes, or frequently, certain items must be never together, and in this case, do the opposite. Okay? So let's do an example here. How many arrangements of the word active if C and E must never be together? So what we're going to do is we're going to figure out the total ways, and then we're going to subtract the ways C and E can be together. All right? So before we figured out the total ways, and we multiplied it by the ways to arrange POS, we're going to do something similar here. So the word active, C and E must never be together. So let's treat them as if they are together. So we got these 5 tiles. What am I missing? 2, 3, 4, 5. Okay. So the total ways, so if we were just arranging like all the letters, there's going to be 6 factorial, okay? And we are going to subtract the ways C and E can be together. So that's going to be 5 factorial. And then C and E could be C and E, or it could be E and C, so we multiply 2 factorial. So altogether, we get this 6 factorial minus 5 factorial, 2 factorial, and we're going to have 480 ways to do that. The last example here on this page is very similar to what we just did. So the total ways, there's 7 letters in this word. So we're going to take the total ways and we're going to subtract vowels. Okay. So the total ways is 7 factorial. And the vowels together, let's draw a little diagram. You have O and I are the vowels. And W, R, K, and G. So there's 6 tiles. And then we can also arrange the O and the I. So 6 factorial, 2 factorial. And here we're going to get 3,600 ways that the vowels can never be together.